electrons moving through, almost just like a glue. From anode to cathode, yeah, you said it, and they go right up the potential, yeah, they making that flow. At the anode oxidation, it occurs. The electrons, they don't like that, they don't like to be secure. They bite back and they fight back, and back away they flow through the volts and through the wire, through the metal, yeah, they flow. Galvanic cells, they spontaneous, so the G be negative. Lytic cells don't believe, keep their G positive. Anode, it's a metal, it decreases. Ions leave with a goodbye. Cathode's mass increases. Ions show for a good time.
Welcome to our presentation of electrochemical cells. You've already seen our amazing wrap. Now you'll see an overview of electrochemical cells. You'll see the differences between galvanic cells and electrolytic cells. You'll see two practice problems, one with us and one by ourselves. Here's an electrochemical cell. An electrochemical cell is a device that transfers energy through either galvanic or electrolytic cells through a redox reaction. They consist of two different electrodes. The anode, where oxidation occurs, or the loss of electrons, or the cathode, where redox occurs, where the electrons are given to. These electrodes are placed in electrolytic solutions, and a salt bridge allows the ions to move between the solutions to keep the charges balanced. The electrons move from anode to cathode.
Alright, so now we're going to go over the differences and similarities between the galvanic or voltaic cell and the electrolytic cell. And for the galvanic cell, it converts chemical energy into electrical energy, and it's spontaneous. So that means that the Gibbs free energy constant is less than 0, and the anode charge is negative, and the cathode charge is positive. And then for the electrolytic cell, it converts electrical energy into chemical energy, and it's not spontaneous. So the Gibbs free energy is greater than 0, and the anode charge is positive, and the cathode charge is negative.
So now I'm going to do an overview of galvanic cells. So when the anode is a metal, its mass decreases as the anode is converted into ions. And when the cathode is a metal, its mass increases as the cathode gains electrons from the anode. To calculate the voltage present in galvanic cells, we use the equation E cell equals E cathode minus E anode to determine which half cell is actually the cathode and which is the anode. Cathodes generally have a higher voltage, and the anodes will generally have the more negative voltage.
Alright, so which of these is going to have a higher cell voltage? An aluminum and a copper half cell, or a zinc and a copper half cell? All of it at standard, at 25 degrees Celsius in 1 molar solution, which is standard. And standard reduction potential should be here. Pause. Alright, so here's the answer. Did you get it right? If not, it's probably because of this reason. So, as you can see, the voltage of the copper and aluminum cell was actually greater than the voltage of the copper and zinc cell. So what you might have done wrong is in the equation, you can see that the anode, you subtract that voltage, you subtract that half cell voltage. And what you might have done was you might have subtracted the voltage itself. But since it's a negative, times a negative, right? That's actually gonna add to it. So the bigger the difference between the two half cells is, the greater the voltage is gonna be. So that's what you wanna look for if you wanna check your answers. All right, new practice problem. Which way is the current flowing in this cell? Is it this way or this way? Next, write the full net ionic equation of this reaction. And then, is the delta G positive or negative, the Gibbs free energy?